Welcome to the Home's Electrical Systems course organized by NPR Online Technologies. Before starting the video, we recommend that you subscribe to our channel and visit our website npronline.tech. In this lesson we will see how to turn on light bulbs from a practical point of view, by applying the theoretical concepts illustrated in the previous lesson. In the previous lessons, we have dealt with the main concepts concerning the power line. We also illustrated the approach we will adopt to simulate an electric power line using a simple battery in order to avoid any risk related to electric shock. The first experiment in order to check if our power line is working properly consists in turning on a light bulb. As already seen in the theoretical section of this course, the light bulbs in our homes are designed to work with a specific voltage, for example 230 volts for European countries. It is obvious that these light bulbs cannot be turned on if they are powered with a 9 volts battery. This problem can be solved by working with lamps designed to work with low voltages and low power that can be easily found in electrical stores. Specifically, we refer to LED or halogen lamps capable of operating with a voltage of 12 volts and with powers lower than 10 watts. These are exactly the lamps that we will use in our course. These 12 volts lamps have two terminals, exactly like the 230 volts light bulbs, and therefore the wiring techniques we will use during the course are the same used for 230 volts lamps. Now a simple question arises: how do we connect the wires to the lamp? We can use a light bulb socket, also known as light socket, lamp socket or lamp holder. It is a device which mechanically supports and provides electrical connections for a compatible electric lamp. One of the typical connection used for the light bulbs is the Edison screw, where the light bulbs have right-hand threaded metal bases which screw into matching threaded sockets. In this case, the lamp holder is equipped with two terminals for the connection of the hot and neutral wires. Screws are available to make the connections tight. In this way, after assembling the lamp holder, the hot and neutral conductors are connected to the two contacts of the bulb holder. The light bulb can then be screwed into the lamp holder and subsequently connected to the socket via a plug. In the case of our 12 volts lamps, we can purchase a suitable support or connect the conductors directly to the two contacts of the bulb using simple screw terminals. Let's consider this second solution. We observe in particular that the red wire coming from the positive pole of the battery is connected to the brown wire to indicate that we will consider it as the hot wire, while the black wire coming from the negative pole of the battery is connected to the blue wire to indicate that we will consider it as the neutral wire. The brown and blue wire are then connected to the two contacts of the 12 volts halogen lamp via other screw terminals. Now let's try to make the connection with the 9 volts battery, which is our simulated power line, and, if everything has been done correctly, the light bulb will turn on. It is observed that the brightness of the bulb is quite low, and this is primarily due to the fact that we are powering it with a 9 volts battery that does not fully meet its required voltage. However, it is clear that this is absolutely not a problem as far as our exercises are concerned. It is also noted that the used lamps do not have a polarity to respect, and therefore if we reverse the connections, the bulb will continue to light up. In other words, if we change the polarity of the battery, the light bulb will continue to stay on. In the theoretical lessons we have explained that the cables of our electrical systems are housed in plastic or metal tubes possibly embedded in the ceiling, walls or floor of our homes. We can see it is a flexible corrugated PVC tube with a length of 5 meters and a diameter of 20 millimeters. The diameter of the pipe must be chosen on the basis of the number of conductors that must pass through the pipe and their cross-section. Where possible, it is convenient to use pipes with a larger diameter than necessary. This allows easier operations where it is necessary to add more cables or replace the cables with others having a larger cross-section. We can also see that the tube is equipped with a metal wire for pulling of cables. This last aspect will be clearer later. Well, let's go back to our simple circuit that turns on a single light bulb. As happens in real electric installations, we need now to pass wires through the pipes. To do this, we must first disconnect the brown and blue wires from the circuit. Subsequently, it is necessary to cut with a knife a piece of pipe a few centimeters shorter than that of the blue and brown cables of our circuit. At this point we can proceed with the insertion of the brown and blue wires into the tube. You will notice that, even though it is a tube of a few centimeters, this operation is not so immediate, since the wires tend to get stuck inside the tube. We can therefore imagine that such an operation is impossible in the case of pipes with a length of several meters with multiple curves that prevent the cables from advancing during insertion. The metal wire inside the tube comes to our aid. We have seen in fact that there are available corrugated flexible tubes already equipped with a metal wire which is already inserted in the pipe and facilitates the insertion of the conductors into the pipe itself. More specifically, the brown and blue wires are tied to one end of the metal wire using electrical tape, and then they can be easily pulled from the other end of the tube. As an alternative to the metal wire, cable pulling probes are available in electric stores. These probes are more robust and their use is similar to that illustrated for the metal wire. The pulling probe is a flexible and at the same time rigid wire with a rounded metal tip at the front end to overcome the curvature of the pipe. Well, now that the hot and neutral cables are inserted in the tube, we can connect them with the appropriate terminals to the 9 volts battery and then to the lamp. We can see that, with the help of the electric tape, the circuit has been installed on our work table. More specifically, we can see the 9 volts battery, the 9 volts battery clip connector, the 2 wires, the corrugated tube, and finally the lamp. Well, we have come to the end of this lesson where we have seen how to turn on a light bulb by simulating an electric power line with the help of a low voltage battery. We have also used our work table for the installation of our first electric circuit. We suggest you immediately consolidate the concepts you have just learned by carefully reviewing this video and above all by going through all our other videos on the subject, by accessing our playlists. We remind you that our NPR Online Tech website is active with numerous insights on these issues. We also suggest some useful actions that will undoubtedly contribute to the growth of this channel. In particular, we invite you to send us your comments, to like this video and share it with your friends. Finally, don't forget to subscribe to our channel to stay up to date on all our activities. Thanks for your attention and see you next time.